All right, and we continue the previous video. Okay, use the graphing utility to find the line of best fit. All right, we're still gonna use the data in table 6 from example 1, and then we're gonna do the following 4 steps. Okay, first, use graphing utility to find a line of best fit that models the relation between on-base percentage and the run scores. And then B, we want to graph the line of best fit on the scatter diagram obtained in example 1B. And then we interpret the slope. And then D, we use the line of best fit to predict the number of runs a team will score if their on-base percentage is 33.1. Okay, so we need to use graphic calculator. All right. So earlier we already entered the data. Okay, let's double check in the stat function and then enter edit tab. Okay, we already have both data, okay, entered from last section, right? Last video. And then how to call the linear regression function. And we also graphed, right? Oh, I'm sorry. Let me clear this one. I already did. All right. Let's graph it. That's the scatter data plot, right? That's what we got last time. So now we want to find the linear function best fit model, right? So we still need to call the statistic function by press the key stat and then use the arrow key, move to the next tab, calculate, okay? Abbreviation as calc. And then there are two options here we can choose from. Okay, we need to call linear regression function to find the linear model best fit the data. And you will see option 4 and option 8, they're both linear regression functions. Okay, the only thing different is the form of linear function is different. Option 4 is given in the form ax plus b, which means a returns as a slope, b as the y-intercept. Okay, but in option 8, a is the y-intercept, b is the slope. Okay, they're exactly the same. Okay, they will get exactly the same linear regression function. So just the format is a little different. So it really doesn't matter, okay, which option you choose. So since linear function standard form we learned from chapter 3 as y equals ax plus b, right? Or y equals mx plus b. So it's more match the option 4. So I'm going to use option 4, okay? So when you press option 4, and then you will see there are 5 rows, okay? The first row we will keep as the default. We want to hit the calculate, okay? So you can use the arrow key, move it down, or you can just press enter. The cursor will move down until highlight the calculate and then press enter, okay? And then you will see y equals ax plus b in this kind of form, okay, linear function, and then a equals this number, b equals this number, okay? R square is another statistics we do not use in this class. R is the correlation coefficient, okay? R is a correlation coefficient. R value is from -1 to +1, okay? Cannot less than 91, cannot more than +1. So what R means, if R value is 0 or close to 0, 0 that means the two variable x and y have no correlation, no linear correlation. And then if R is more close to +1, that's indicate it have a positive correlation, which is the line slope is the increasing line, okay? If R is a negative number close to -1, and then it's a negative strong correlation, okay, between two variables. All right, so the linear function or linear model we find is, okay, let's keep 2 decimals. So that will be a equals 49.40, right? That's the slope of the line. B is negative 906.29. We keep 2 decimals. So put a backdoor behind the 9 and then look at the backdoor. Who is the backdoor? 3, right? 3 less than 5. So we will ignore rest of the digit, including the 3, right? And then for the slope, put a backdoor behind the 9, and then who is at the backdoor? 5, greater than equals 5. We need to add a 1 in the previous digit. So that change to 0, this change to the 4. So 49.40. Okay, that's how we model this linear function. So slope is 49.40, and then y-intercept is negative 909.29. So now we put linear function, okay, into calculator so we can graph it. So we use y equals, right, to enter the linear function, which is 49.40. I don't have to type 0, right? X, and then minus 906.29. Okay, that's the linear function. y1 equals 49.4x minus 906.29. And then after we put a linear function in the calculator, we can graph it. So that will together with the scatter data plot. Okay, so this linear function or this line is the best linear model fit the data set. All right. So you may wonder how we get this line or how we get a and b value for the linear model. The function, okay, for calculate this is called the least square function. Okay, and we minimize the least square function. So what it means is we're looking for the line which is each point, okay, have the shortest distance from that line, and then minimize that function. Okay, and then that's how we got this linear model, okay, which is the slope and the y-intercept. Okay, all right, and then let's see what the other one we want to do. So we got A, right, done, and then we got a B done, and interpret the slope, positive slope, right, 49.40. So what that means? That means every 1 unit change in the independent variable x and y change by 49.40, right? So in this specific case, that means the on-base percentage, right, increased by 1%, and then the run score is increased by 49.40. All right. So that's how we interpret the slope. And the last part, use line of best fit to predict the number of runs a team will score if their on-base percentage is 33.1. So we can still use the graphic calculator, right? And then remember, evaluate function. And then we want to evaluate y variable, right? And then we put a function into y1 and then pass the parameter 33.1. Is that right? 33.1. And then close parentheses, press enter. So we got a 728.85. If we round it to the integer, that will be about 729. Right, let's check. Are we good, right? Yeah, 729 run, approximately. All right. So this is the graphic calculator output. And some of you, when you call linear regression function, you may not see. Okay, let me just show you again. Okay. Oh, it's wrong. Sorry. Calculate, and then option 4. So some maybe you only get a y equals a equals b equals. You don't show r and r squared. Okay, I can tell you how to show that. You press second and then 0. We want to call the catalog. You need to turn the statistic diagnostic on. Okay, you need to turn that on in order to show that. So you need to scroll down to the function start with d. Okay, right here. Diagnostic, you need to turn that on, which is, okay, I'm turned it off first. Okay, so you will see the difference. I'm already turned it on, but I just want to show you. Okay, turned it off. Okay, and then I call the linear regression function, and then you will see it doesn't show R and R square. Okay, right? This is what you may see on your graphic calculator. Okay, without R and R square. Now I'm going to turn it on again. Okay, by press second 0, call the catalog, and then we turn the diagnostic on. Scroll to the D function. This is based on the alphabet order. Okay, now diagnostic on, right? I want to turn it on. So press enter. So now the function name get on the calculator screen. You press enter one more time. Okay, and then now it's turned it on. So it said done. That means already turned on. All right, let's go back to the linear regression function. Press stat and then calculate, and then option number 4. Okay, and then press enter until hit a calculate. So now you'll see R and R square is on. Okay, so if you're interested in see what's the difference between option 4, option 8, I'm gonna show you also. Okay, press 8, and then you will see we got exactly the same result, just A and B value switch. Okay, so A equals negative 906.29, B equals 49.40 if rounded to, right? R square. They're exactly identical result, just the, A and the B value, what it represent. Okay, in this case, A plus BX, so A is the y-intercept, B is the slope, right? The other way is A represent the slope, B represent the y-intercept, right? But we got exactly the same value, right? All right, so this is 4.2. Okay, we're done today.